Hi everyone, I'm Trevor Williams. I've been designing database systems for over a decade now, and I'm here to ensure that you learn Transact SQL, or T-SQL for short, which is the premier language used by Microsoft for their SQL server.
Hi there, I'm Emma Morrison, a SQL Server specialist with almost a decade of experience managing databases and analyzing data using T-SQL. Together, we'll explore the world of T-SQL and its importance in data manipulation and management.
Now, why is this a good course? T-SQL, or Transact SQL, is Microsoft's adaptation of SQL, meaning it is used in Microsoft SQL Server, which is one of the most popular database management systems in the industry.
Our course will be much more than theoretical knowledge. We have designed it to be highly interactive with plenty of hands-on exercises and questions to test your understanding. Plus, we have included a bunch of practical scenarios where T-SQL shines so that you can see it work in real-world scenarios way beyond the textbooks.
Having a thorough understanding of T-SQL is important for anybody who is serious about advancing their career in data management, data analysis, or related fields.
Finally, you'll benefit from our course because we'll be there with you every step of the way, guiding you, answering your queries, and ensuring you understand the T-SQL language thoroughly. You'll also be a part of a growing community of learners, allowing you to network, collaborate, and engage with like-minded individuals on a journey just like you.
Now, why should you enroll in this course? Our world is heavily data-driven, and having a good understanding of Transact SQL can open up many doors for you. Whether you're a software developer, data analyst, or just a hobbyist, knowing how to navigate, manipulate, and manage data using SQL will greatly enhance your capabilities, and it is a vital skill for this day and age. So join us in exploring this powerful language, and we're excited to meet you, and we can't wait to have you along for this journey.
Before we get into working with SQL Server, it's probably a good idea to talk about what SQL Server actually is. SQL Server is a relational database management system, or RDBMS. It uses a database engine to handle all the tasks associated with storing and retrieving data from a database, creating new databases and their components such as tables, views, and stored procedures. Because of its nature as a server, it's typically always running on a computer that it's installed on, ready to respond to requests, to perform required tasks, and then serve the information back out to the user that requested it. In most production environments, SQL Server would be installed on a dedicated machine, and users would log in remotely from their own computers to access the databases that they want to use. However, SQL Server can be installed on a local computer. This approach simplifies the connections and is the method we're going to be using for this course. A SQL Server installation is called an instance, and a single instance can hold many individual databases under its umbrella. You might have one database to track your product offerings and a separate database to contain employee records, all on the same instance. You can install up to 50 instances on a single server, however, this is not recommended. At the heart of SQL Server is something called SQL or SQL. SQL stands for Structured Query Language. It is the standardized way database administrators, developers, data analysts, and engineers interact with most of the database systems on the market today. In the next lecture coming up, we'll be taking a deeper look at what is SQL. As you'd have learned in the previous lecture, SQL stands for Structured Query Language, which is a language for manipulating and defining data in databases. It first came into use in 1974 and became the standard in 1986. SQL gives us a standardized way of asking a specific question of a database, or for making structured query that a database knows how to respond to. So what SQL does is that it pretty much gives us a way for writing questions a database can understand. Databases aren't clever like us, and they can't figure out the meaning of questions the way human can. If you are supposed to ask a question like, how many goals were scored by France in the 2020 World Cup finals, you, a person, could pretty easily understand what I'm asking you. But ask the database the same question, you'll probably get whatever the computer equivalent of a blank stare is. The database doesn't know how to understand the meaning or the intention of my question. To make questions like this approachable for a database, we need to break them down into a series of smaller questions that are structured in a way that the database software can understand. Because it's such a powerful way of thinking about data, SQL has been adopted into many database products. In this course, we'll cover the basic and widely supported parts of SQL, whether you're working with Microsoft Transact SQL or T-SQL, MySQL, Postgres, or even SQLite and other databases. The way we say the name may be a bit confusing sometimes. Sometimes I use SQL, sometimes I use SQL. It all depends. So before we start building out SQL statements, we need to understand what the basic parts of a statement are. Overall, something you write in SQL gets an answer from the database or make a change to it is called a statement. SQL is generally whitespace independent, meaning if you want to add some white space or lines between clause or expression to make your statement easier to read, you can do so. In this course, we'll break statements across various lines in order to make them more clearly readable. I find it really helpful when I'm putting together a more complicated statement so I can see what's going on. A statement is made up of clauses. Don't worry too much about what this actual statement does right now. We'll see how to make clauses and statements later on in this course. Clauses are the basic components of statements, the smaller building blocks that make up the whole thing. These clauses are constructed out of various elements including keywords, which are special or reserved words which tell the database to take some action. Field names, which let us refer to fields or columns of data whose value we want to use. Table names, which tell the database which table to use. And predicates, which we use to specify the information or condition we're looking for. Predicates include a value or condition called an expression. A clause can be a statement if you are writing a really basic one. There are also operators, as we'll see later on, which let us compare equality or ranges of data or treat information in other ways. These keywords and operators are customarily written as uppercase, though usually they don't have to be. But it helps to distinguish the SQL from your expression and field names at a glance. At the end of the statement, we put a semicolon. This simply tells the database the statement has ended. While the semicolon is often required in order for the database software to accept the statement as valid, not all database software or database engine enforces this. So it's a good idea to get into the habit of using semicolon to end a statement, as you'd use a period to end a sentence. Any SQL we write that takes some kind of action is a statement, and sometimes you'll see statement using the select word, often called a query. A query suggests that we are asking a question, and when we are using the select keyword, that's generally the case. SQL statements can also be used to add, modify, or delete data in a database, or even create, modify, and remove tables. When we use SQL to work with data in existing tables, that's SQL being used as a DML, or data manipulation language. These operations where we change data are generally called CRUD, shortened for create, read, update, and delete. CRUD is a command shorthand for referring to modifying data in a database. When we write SQL to make changes to the structure of tables themselves or change the database, that SQL been used as DDL, or Data Definition Language. In this course, we'll focus on all the correct operations, as at the end of this course, we want you to be a pro in SQL to help take your career to the next level, whether it be data analytics or database development. Why learn SQL? Simply because SQL skills are among the most in-demand IT skills, and they have been for several years. In today's digital world, knowing at least one computer language is mandatory for good career opportunities. That's the ultimate reason why you should learn SQL, an easy and highly universal language. Now, if you aren't sure where to start, you have selected the right course. Learning SQL is beneficial for several reasons. First, database management. SQL is the standard language for managing and querying relational databases. It allows you to interact with the databases, retrieve data, modify data, create and manage structures, and perform various administrative tasks. Secondly, data analysis. SQL is a powerful tool for data analysis. It enables you to extract, filter, and manipulate large data sets efficiently. You can write complex queries to join multiple tables, aggregate data, calculate statistics, and generate insightful reports. Thirdly, data integration. Many applications and systems rely on database to store and retrieve data. By learning SQL, you can integrate and communicate with these databases effectively. It enables you to extract data from different data sources, transform it, and load it into your application or reporting tool. Fourthly, career opportunities. SQL skills are highly sought after in the job market, especially for roles in data analysis, data administration, and software development. Proficiency in SQL can enhance your employability and open up a wide range of career opportunities. And last but not least, efficiency and productivity. With SQL, you can perform complex data operations with minimal code. It allows you to write concise and optimized queries, which leads to improved efficiency and productivity in data-related tasks. Overall, learning SQL empowers you to work with databases, analyze data, make data-driven decisions, and pursue a successful career in various fields involving data management and data analysis. Databases and structured query language were nearly synonymous over 3 decades. SQL was required for everyone who wished to obtain data from a database. There was no SQL alternative, and anyone who wishes to maintain databases or work as a database administrator had to learn the intricacies of the system. However, there are several alternatives available today, and I'll be naming a few of them. So the first one is PureQL, pronounced Prequel. This stands for Pipelined Relational Query Language. This language's data querying system are made up of a series of tiny instructions. When all the instructions are combined, you'll obtain the results that only contains the information that you need. Another alternative is GraphQL. The name is a little misleading because it isn't truly a language built to make use of all the benefits of graph databases. GraphQL is more of an elegant shortcut for accessing data stored in layered JSON-like format. The query is just a description of how the results should appear. The third one is Malloy. The problem with SQL, according to the creators of Malloy, lies in the syntactic details. Expressing even the simplest of query takes time because the language is verbose and is full of hidden performance traps. So they created a modern programming language with natural defaults, simpler syntax that can be used to compile SQL. So no one needs to retrofit a stock database. The last one I'll be talking about is NoSQL, pronounced Nickel. This is designed to make it easier for SQL alternatives to work with JSON objects that might be stored in Couchbase. A basic query has several sections, specified by the keywords select, from, and where, just like SQL. However, this is just a few of them. And if you want to learn more, I'll leave a link in the resource section so you can do some additional reading.
Alright guys, in this lesson we're going to be looking at setting up SQL Server on our machine. Now, finding SQL Server's installed files is as easy as a Google search. I literally just Googled SQL Server and the very first search result is good enough for me. You'll see that you have different tools or different years. So based on your machine, you may want to choose a version that is in keeping with the specifications of your machine. But at this point, I'm going to install the latest version, which is 2019. So just by clicking that link, it will bring me to the download for SQL Server 2019. And then I have a few options. I can, one, install on Windows, Linux, or Docker containers. There you go. You have the different installation instructions, and you have other things that you can look at. But we really want to focus on the free versions, which are the developer version and the Express version. So Express is a free edition that is ideal for development purposes and for very small applications on servers or desktops, whereas developer is full featured. So you actually have different editions like professional and enterprise. And you'll see here that you have Azure and on-premises, and it varies based on it. But then based on the version that you select when it comes to on-premises, you realize that you have an evaluation for the enterprise edition or the professional edition, etc. Right? So you can look through them, but at the end of the day, we want to go with the one that is free for development and educational purposes. So in this course, I will be using Express. That being said, everything I'm about to do in Express is also available in Developer. However, Developer has a lot more that is available. But for learning purposes, and just because I don't know where everybody's machine capabilities are, we can start off with Express. So when you click download now, you will get an installer file which you can launch immediately, and you might get prompted by your machine like I just did. But this is what that installation looks like. So you have basic, custom, and download. Now I'm using Express because the setup is easy and it's very easy to maneuver with. So you can go ahead, hit basic, accept, choose where you want it to go, if not the default location. Make sure you have enough space relative to the download size, and then you can hit install. Now, when that installation is done, you're going to see some pertinent information being presented to you. The first thing that stands out is the instance name. You're going to see SQL Express. I have SQL Express 01. The only reason for this difference is that I already have SQL Express installed on my machine. So in other words, I have one version of SQL Express installed, and I'm installing another one, and for every time I would install, I would get a different instance name. An instance is like a container that has all of the databases in it. So based on the instance that you connect to, right, then you would be storing your databases on that instance. You don't need to install multiple. I'm just explaining why I have a different name from you. If you have gotten to this page successfully, then you have successfully installed an SQL Express instance on your machine. No need to worry. They also let you know that the administrators would be your machine name / your username, and the engine and everything, and connection strings and some other bits of data that you don't necessarily have to worry about right now. The next major step would be to install the SSMS, which is the SQL Server Management System. So this is the user interface that will allow you to administrate your instance, set up your databases, your tables, and everything. So you can go ahead and hit that, which will launch a new window in whatever browser is your default browser, and then you can just download that version that is available to you. So when you finish and you install that, and the installation of that is fairly simple and straightforward, you'll get this prompt and you just click install and next to it. So I'm not going to walk you through step by step. It's fairly straightforward and you should not encounter any major issues. Now, when all of that is done, you would have completely and successfully installed SQL Server on your machine, whether this is your personal laptop or a server laptop, it is now capable of hosting and administrating databases. So stick around, because in the next lesson, we're going to look at how to connect to our database and start interacting with data. Alright guys, so in this lesson, I want us to take some time to get familiar with the SQL Server Management Studio, or SSMS. It is a very powerful tool, and it helps when we know some keyboard shortcuts, some ways to navigate around it and get comfortable. So to open it, if you had closed it since you did the installation, you can always click in your search bar and go to SQL Server. Of course, if you're not using a Windows computer, then you would launch that Docker container that you would have installed. But once you have launched it, it will take some time to load. And once it's up, it will prompt you to connect to the server. Now, some things to note here. Our server type is database engine. The server name refers to the name of the instance that you are connecting to. So when you would have installed SQL Server Express, then your instance would be localhost/SQL Express. All right, just so we're clear. So to get in, if you installed SQL Express, you would say localhost, then the backslash, and then SQL Express. Another way you could write this would be your machine name. So here my machine name is SQL, so I could have easily said SQL backslash SQL Express. I named my machine simply enough for the purpose of this course, but you might not have a simple enough machine name. So you could say, your machine name, you could say localhost, but the easiest one is the full stop. So you can say full stop, then the same backslash SQL Express. Any of those will allow you to connect to your SQL Express instance. Now, if you were using Docker, you would have started your container that would contain your SQL instance. So you can go ahead and start it. And then when you're connecting to it, you would use localhost, comma, and the port that you had specified during setup. So once you specify that, you also have to change the authentication to SQL Server Authentication. And then the login would be SA, and then you can connect. Of course, while setting up the container, you would have put in whatever login name and password you'd have preferred. So you can go ahead and fill those out, and then you can connect to your instance. Now going back over to connecting to the SQL Express instance, once I click connect, it takes a few seconds and then it launches this section in the Object Explorer. So our Object Explorer, which we can pin or hide at will, it shows us all of the objects that are currently in this instance. So you are actually capable of connecting to multiple instances on this same machine. So I have another instance on this machine as well. And each time you install SQL Server, you would actually get pretty much a new instance. So I can connect to another instance called localhost. So within a scenario where you may be working with multiple computers that are database servers, you can connect to multiple instances in the same setting here using the Management Studio. Now let's revert to a scenario where we only have our one instance, and you can use this plug to launch the connect to server window. You can also use this one with the X to disconnect from an instance to which you may already be connected. Now, if we expand the databases folder, we'll see that, well, nothing is in it. We haven't gotten around to creating a database just yet, but we do have some sample databases, or some system databases rather. They're not samples. They shouldn't be played with. So I would advise not to modify any of these unless you have absolute mastery of SQL Server Management. So these are some default databases that are required for the operation of the database instance. So those are the databases that we get, and later on we will see how we can create our own databases. But other options that we have access to, we can access security options, we can look at different logins and the credentials and roles for the server, and other auditing and more advanced things that are outside of the scope of this particular course. Now, a key feature of using the Management Studio is the ability to write a query. So a query is written in a language called SQL, which we're going to look at. But when you want to write a query, you have two options to launch the text editor that allows you to write a query. You can either click New Query up top here, or you can use the keyboard shortcut Ctrl+N. So if I use the keyboard shortcut Ctrl+N, it is going to launch a tab that contains a text editor that allows me to write whatever I need to write. Of course, it is within the context of SQL, so this gibberish will not go down so well in the context of what it expects. Now, a few things to note here. One, when I write a SQL query, let us say I write a simple query like select name, database ID, create date from sys.databases. Now, you can take the time and rewrite this, of course. You can hit pause, replicate it. But once you write it and you want to see the results, let's do that again from scratch. I preempted that. So to get a new query window, all I have to do is Ctrl+N or click New Query. So you can have as many query windows as you may need because you'll be working with multiple databases or multiple tables at least, and you may need to separate your queries. Now, when I write this query and I want to see the results of this query, I can click Execute. So I can click Execute or I can press F5 on my keyboard. So whichever one will actually execute this query and it will show us the results in the bottom section. Now, another thing that you want to take note of is the active connection or the active database relative to the script. So whatever database you see here is the database that is going to be affected by the script or that the script will be run against. So when you have multiple databases, then you want to make sure that the correct database is here. And if you click the drop down list, you'll see all the available databases in the system at this point. So if I try to run the same query against a different database, it will still work because this is going to sys, right? But then if I try to run it without that sys, I am going to get an error here, right? Because none of these objects exist in this database. If I try master, MSDB, or even tempDB, all of them will give me the same issue. And if I try to execute, I will get this error message below saying that this is an invalid object name. So anytime we run a query that it's not quite familiar with, we might see the red lines. And it's just that the Management Studio needs to recontextualize itself. But if we click execute and it is not a valid query relative to the database that we are using, then we're going to see an error message looking something like this. So these are some visual cues that can help you along as we build out our database. Of course, I'll be giving you more tips and tricks, but for now, I just wanted to give you a quick introduction to the Management Studio and how it helps us to construct queries and carry out our operations. Now, the final thing that I want to share with you is the fact that we can actually save our queries, because queries are they really help with automation, right? So you can write this one time and then you can save the query and then relaunch it at will. So to save the query, it's the same thing like saving a regular text file on a computer. You can either use Ctrl+S, you can click the floppy disk up top here, or you can go to File and click Save. Whichever one it is that you choose to do, the end result will be that it's asking you where do you want to save this query file. So I can say test, or let's say list databases query, and I'm going to just save it on the desktop for easy access, and then I can just click save. Now once I do that, if I was to close our Management Studio and you see it's prompting me that I have another query that I have not saved, would I like to save it? I'll choose not to save that one because that is the poorly written query. However, I saved this one on the desktop and you can see here that I can double click the file and it will prompt me with which app do I want to launch this file. So I'll choose SSMS and I'll tell it to open with that all the time. Click OK. And once SSMS is launched, I am prompted to connect to the instance with which I intend to run this query. And once I do that, you might get double prompted. So let's just connect again. But once I do that, you see it launches the window, it launches everything, and my query is here and ready for me to run. So that is another tidbit as to how you can help your own productivity going forward using SSMS. Now, we will be looking at both scripting and using the UI to complete certain operations, and that is where SSMS really has some advantages because it has a powerful UI engine that gives us tools to do certain operations. For instance, if I wanted to create a database, I have the option of writing the script to create database, and let us say intro DB, right? I can write that script. I can use this to create the database. However, not everybody likes scripting, and sometimes there are some simple operations that you may not necessarily want to go and write a script to do. So you can actually right-click the databases folder and you can actually just create a new database here. So if I do this, create new database, then you're going to see this dialog box come up and I can give it a name, intro db2. Get my spelling right, and then I can click OK, and then that would create the database for me. So as we go along, we're going to look at the fact that yes, we can write a script, but we can also use the UI to complete certain tasks. And of course, we'll look at the pros and cons of either. So those are the things that the SSMS helps us to do, and it makes it really easy for us to interact with our database and the instance. Now, when we come back, we're going to look at some of the differences and similarities between the SSMS and the Data Studio.
In this section, we'll be setting up the AdventureWorks database. Now, this is a database from Microsoft that has pre-populated schemas and data, which is what we'll be using throughout this course. At the end of this section, you'll understand what are schemas and how to perform a backup and restore of the AdventureWorks database. In this video, you'll learn how to set up the AdventureWorks database by performing a restore of the database. Before we download the AdventureWorks database backup, you need to check which version of SQL Server you're using. This is important because you cannot restore a higher version of the database to a lower version of the SQL Server. So for instance, currently I have a SQL Server 2019 edition running, right? So if I download the AdventureWorks LT 2022, if one exists, then when I try to restore that database to the 2019 instance, it will not be restored. However, you can restore lower versions to higher versions, as the databases will be automatically upgraded in the process. So to check your database version, you can use the command select ATAT version. So if you execute this, you'll see the version of your database. So now we need to head over to the Microsoft website to download a backup of the AdventureWorks LT database. So I'm going to minimize this. You can just Google AdventureWorks LT sample database, as well as I'll leave the link in the resource section of this lecture, right? So you're going to scroll down and we want to get the OLTP version. So here I have the AdventureWorks 2022 backup as well as the AdventureWorks 2019. So I'm going to download the AdventureWorks 22 just to demonstrate what I was mentioning earlier. And I am also going to download the AdventureWorks 2019. So I'm going to minimize this. So the downloads were completed. I am now going to retrieve these from my desktop and copy them to the backups folder. If you're not sure where your backup folder is located, right click on your server instance, select properties, select database settings, and then you'll see where your backup location is. So I'm going to select OK here. Now to restore the database, right click on the databases folder, select restore database, select device. Here, select this icon with the 3 little dots. Select Add, and here it took me to the default backup directory. Now if your backups are not in your backup directory, you can browse to locate it in your downloaded folder. So here I'm just going to attempt to restore the AdventureWorks 2022. Select OK, OK, and OK again. As expected, the restore failed. The database was backed up on a server running version 16. That version is incompatible with the server, which is running version 15. So I'm just going to select OK and browse to locate the 2019 backup. Add, select the AdventureWorks 2019 backup, then select OK. Now you can remove the 2022 backup. So select the backup and then select remove. Now select OK. So here when you're restoring the database, you have the option to change the name of the database, right? So I'm going to leave it as AdventureWorks 2019. Then select OK. The database has been successfully restored. So select OK. Now refresh databases. So you right click and then scroll down to refresh. Now here we can see the AdventureWorks 2019 database. In the next lecture, we'll be exploring the AdventureWorks 2019 database. So in the previous lecture, we had successfully installed the AdventureWorks 2019 database. So now we're going to explore the structure of the AdventureWorks 2019 database. So to start, click this little plus icon here to expand the databases. Typically, a database is made up of several objects. You have tables, you have views, you have synonyms. Under programmability, you have procedures, function, database triggers, and much more. Later on in this course, you'll learn more about these. So, what we want to take a look at now is the database tables. So select the plus for the tables. Now here we can see we have a bunch of different tables. So if you look carefully, you'll see a common naming convention among the tables. You'll realize that it has a two-part name. So it has a schema name, and after the schema is the table name. So it's dbo.table name, dbo.database log, which is a table name, and when you scroll down, you'll see that you have human resource, and it continues, then it goes on to person.table name, and so on and so forth. Now, each of these that I just mentioned are called a schema. So you have the DBO schema, which is the default schema, and schemas like human resource, person are all user-defined schemas. In simple terms, a schema is just a logical collection of related database objects. So for example, in the person schema, all the tables within the person schema are associated with a person. All the tables within the human resource schema are associated with human resource. So when you're accessing an object within a schema, you have to specify the schema name. So let me drag this across here. So for example, if you wanted to access the department table, first, you have to specify the schema in which it is located, and then you use a period to get access to the department table. So here I'm just going to do a simple select all from the department table. So here I have to first change the database because currently this session which is open is to the master database. Now here's another thing, without actually changing the database, I could also specify the name of the database, then a period, right? And I'll still be able to access the data within the department schema. So now you'll see that first we have to actually go to the database, then to the schema, and then to the departments table. Now let's execute this and we'll have the result returned. We can change the database to the AdventureWorks 2019 by selecting it from the drop down. Also, you could use the use statement. So I'm going to copy the name. This also works. Now, in this case, I just need to get rid of the AdventureWorks and I'll be able to query the department table. So if I execute, I'll still get the same result. Now if I get rid of the schema totally, let's execute, then it doesn't know where to locate the department table. However, if this table was in the DBO schema, which is the DBO, which is the default schema, right? Then I would be able to access this table without specifying the schema name. So for example, if I grab the AWS build version table and do a select on that table, then I will be able to see the results. Now if I specify the schema, I should be able to see the results. So when you create objects without specifying the schema name, they'll be created in the default schema. So those are the tables. Now let's look at the views. So let's expand views, and here you can see that we have a bunch of views. Don't worry too much about the views though. Views are pretty much virtual tables and are defined by underlying queries. So this query here, I can now create a view on top of this query. Don't worry about this right now, you'll learn about it later on in this course. In order to access the database, you have to have users. So I'm going to minimize views under the security, expand logins, and here are the logins that can be used to access the database server. So currently I am logged in as SQL admin. Now when you're logged in as the admin user, and this user has all the permission that I need on the database. However, I am not going to be going deep into security because that's database administration. So when you look in the login section, the user that you are logged in has, you'll see it right here. Or if you enable the SA user when you are creating the instance, then you will not see a disable icon here. Another important part of the database is the database diagrams. This will give you a graphical representation of how your database looks. So basically, this will show you the relationships with all your tables. So here, you'll see the database diagram. Now when I click the plus icon, it says, the database does not have one or more supported objects required to use database diagramming. Do you wish to create them? Sure, so I'm going to select yes. Now let's refresh again, expand. Now right click on the database, select new database diagram. Now it's a bunch of tables, so I'll be just adding a few so you can see what the database diagram looks like. Tables, so I'm just going to select close here. Now here you can see a graphical representation of the tables. So these tables at the top are tables that do not have any relationship based on the tables that I've added so far. Now when you scroll down, you'll see that the employees department history is associated with the department table and it is related by the department ID. So you can scroll across and scroll down and you'll see the rest of relationship of how the tables are integrated. However, later on down in this course, you'll learn more on how the tables are actually related by primary keys and foreign keys. So to summarize, a database is contained of different objects such as tables, views, store procedures, and triggers. And these objects are typically grouped by a schema, whether it be the default schema or a user-defined schema.
Alright, so in this lesson, we're going to look at a select statement. Now, basically with databases, there are 4 fundamental operations that you would carry out when it comes to interacting with the data. And they are characterized by an acronym called CRUD. The C is for create, the R is for read, the U is for update, and the D is for delete. Now, in looking at select statements, we're going to be looking at doing read operations because the reality is that to see the data, we need to be able to read the data. Data has to be present, and we are starting off with the AdventureWorks database that you would have set up by now. So there is data there for us to work with, and what we're going to do is focus on different scenarios and different ways that we can interact with the data so that we can have it in a presentable manner for our use. So I'm already connected to my database instance, and I have my AdventureWorks database, AdventureWorks 2019 database, and you would have already done your setup as well. So let us start with a basic select statement. The first thing that I always try to put in my SQL scripts before I do anything else is the use statement. So I can use and then specify that I am using AdventureWorks for the next set of queries. And then let us say that we wanted to select all. So I'm just going to kind of write the scenario above in a comment. So I want to select all data from a table. Something nice and simple. So to select all the data from a table, that means I need to have what we call a select statement. So select, which is a keyword, and then I'm going to say asterisk or star, right? So all we have to do is put that symbol, that asterisk, and then you say from, and then you specify the table that you want to select everything from. Now, with the AdventureWorks database, do recall that we have what we call schemas or schema names before each table. By default, we get DBO. However, when creating the table with a specific schema, you're going to end up with that specific schema preceding the actual table name. So when you want to select from that particular table that has a schema that's not the default, then you want to fully qualify the name, meaning you're going to specify the schema dot the table. So here I'm going to do the employee table because we had some experiments earlier in the course with what an employee table might look like in a database called AdventureWorks. So I feel emotionally attached to this one, if you will. So when we say select star from human resources dot employee and run this, it does the use statement, then it goes searches for that schema and that table in that schema, and then it brings back all of the data in this grid. So from here, we can see the different columns and the different values per column. And remember that the columns represent the data points, and then the rows represent the actual record. So here we have that layout. Now, there are certain indicators that we can use to inform how many records came back. If you look in the bottom right-hand corner of your management studio, and I'm sure it's in a similar position in the data studio, then you'll see the number of rows that the square brought back. Now, this query can be a resource-intensive query. The bigger the table, the slower your machine. So if you had a table with tens of thousands of records, you probably wouldn't want to just do one big select to get all of them, right? So typically, you would do a select maybe just to get a snapshot of what is in the table. And to get a snapshot, you don't need every single record. You probably just need like the first 100 or the first 1000, something like that. So here's another scenario then. I want to select the top 100 records from the table. So this statement is going to say select, then we say top and a numeral, which in this case would be 100, it could be 1000, whatever that number is that you really want to see. Then you specify that number, and then we still say star, and I'll go into another scenario now where we might not use star, and then from, and we're selecting from the same human resources dot employee. So I'm going to comment this one out so it doesn't run again. And then when we press F5, now we're seeing only 100. If I only wanted to see 10, well, guess what? Top 10 gives me the first 10 records. All right, so that's how you can now limit the number, and it will run much quicker against a much bigger data set, and it's just more efficient. Now, I just mentioned that there are scenarios where you won't use star, and the star there, or asterisk, however you want to say it, but generally speaking, you say select star. So I'm going to keep on using that speech pattern so that it sticks, because that's generally how it is said. So when you select star, what you're saying is that you want every single data point for every single record that you are selecting from that particular table. The fact is that you may not necessarily want to see every single one, because you probably don't need to see the row GUID. You probably don't need to see the current flag, and especially if you're doing this for like a report. So you can actually go ahead and filter out the exact columns. So I'm going to say, let us select specific columns from the table. All right. So here I'll say select again. So I hope you see the common theme. Anytime you want to read data, it's a select statement. Now, instead of star, we're actually going to specify the column names that we're interested in. So if I wanted to see maybe that employee's login ID and their job title, and maybe their hire date. Let's just say those are the three things that we're interested in: the login ID, what they do in the organization, and what date they were hired. So I can actually say select, this is the column, login, ID, and then comma separate all of the columns that I am specifically interested in. So job title and hire date. And once again, it's not very strict. It being SQL is not very strict when it comes to the casing of your typing, right? So if I say job title in lower caps here, even though it is capital J, capital T, and I just write it in all lowercase, if I was a little slack and wrote login with a common L when it's a capital L, and then I wrote this one perfectly, it's really not going to matter that much. So I'm specifying those columns, and then I still need to state from which table. So I'm still in human resources.employee. And then those errors go away because now it knows which table it is looking for them in. So let me comment this out and then run this statement. And now you'll see that I'm getting the specific columns. Also notice that the column names that are being printed out here in the grid kind of match the same case that I used here, right? So, all of those little things do matter. So if I just correct them based on how they're originally presented, then you see that they'll come back more specifically, right? So that is, in a nutshell, how you can go about using select statements to start looking at the data. But then all we've done so far is filter out columns. What if we actually wanted to filter out records? Like maybe we only wanted to see particular records out of the entire 290 row data set. So in the next lesson, we're going to come back and look at how we, filter data to specific conditions, and how we arrange our data or sort our data. Welcome back, guys. In this lesson, we're going to look at how we select data from multiple tables and combine them into one display. In this context, I already wrote the scenario so that we can get into it. We're going to select employees and the departments that they represent. Now, if you look at the tables, so far we've been looking at HR employee, human resources.employee, and that is where we've been getting the actual data about the person, their job title, etc. However, if you look closely, you see that you also have human resources.department, and you also have employee department history. Now, once again, I'm not getting into normalization and how foreign keys work in too much detail, but generally speaking, when you want to break up data so that you can repeat fewer details across multiple tables, that process is called normalization. And then as a result of normalization, you end up with, multiple tables as well as foreign keys between the tables. So it is up to you as the data analyst, the person manipulating the data, once again, to be able to assess the different tables, to see the different data and figure out what the foreign key relationship column might be. And then that is what you're going to use to be able to join the tables. So we're going to do some quick queries here, and I'm going to show you guys a shortcut that I haven't shown you before. You probably already figured it out. But if we want to see all the employees without writing out the statement, we can actually just right click here in the management studio, and we can just say select top 1000 rows. That generates the same kind of select top query that we looked at earlier, and it will actually give us the data. And because I highlighted that while I was executing, it stopped. There we go. So at a glance, I can see, okay, that's what the employee data looks like. Now, if I look at the department data, now when we look at the department data, we see that this is simply a list of departments and their names and when they were last modified, and that's fine. But when I'm looking at the data, I'm not seeing anything that would connect the department to an employee. However, once again, here's another table that says employee department history, and this is where naming becomes very important. Just by the name, I can assume or safely assume that this table will contain data about both the employee and the department. So when I look in this table, I would expect to see that there's something here that would be able to link to the department and link to the employee. And once again, naming convention, but also analysis. So if we look at this closely, we'll see that there's a department ID column. This department ID column suggests to me that this is a foreign key to the department ID table. Sometimes, once again, when you're naming your columns, you might name it table name ID or just ID, and the assumption is that it's already in the table. Whichever naming convention works for you. But generally speaking, with the foreign key, would take the naming convention of the table name and ID that it is to link to. So here I can safely assume that this department ID is the foreign key relationship column to the department ID in the department table. So I can use those two to join the data. However, I have to do a bit more digging or analysis now to figure out how do I show that this record relates to an employee. Well, I have business entity ID. And then if I look back in the employees table, there's also business entity ID. So here, I can now safely assume that this business entity ID is associated with this one. Now, it's not as clear as department ID to department ID because business entity ID doesn't necessarily scream employee. However, within the context, it is also a safe assumption. So I just wanted to quickly go through this exercise with you, and we're not going to write any code just yet. I just wanted to kind of break down how data might get spread across multiple tables and the techniques that you need to apply in analysis to figure out how exactly you're going to figure out what should link to what. So now that we have a clear path as to the columns that we need and the different tables that we need, when we come back, we're going to continue with our scenario. All right, so let us start off this exercise, and we're going to be looking at several things in this exercise. One, we're going to look at selecting from multiple tables in one display, aliasing our tables, and I'm going to show you guys some shortcuts so that you can be a bit more productive along the way. All right. So far, when we wrote our queries, we would write them from scratch, select star from, and then try to write out the tables. Well, in this case, I'm going to show you that you can actually drag and drop. So we're going to select, and I'm going to leave star for now and say from. Now I know I need HR. I'm just going to say HR, but when I say HR, I mean human resources. So we need HR.employee. So instead of typing this out from scratch, I can actually just drag it over and look at that. All right, so you can practice that. If maybe you prefer to use a mouse than to type from scratch, that's fine. Remember that you could also just copy and paste. But once again, productivity, find the rhythm that works for you. So we already are familiar with the select star from human resources. Human resources.employee. Now, what we need to do is join this to the employee department history table. Why are we joining these two? Once again, these two have columns in common. So that's what I like to say. They have columns in common, so we can join them based on the columns in common. That means that anything that is business entity ID 1 will now be directly linked to the same row or the row in the next table with the same value. So 1 will be linked to 1. 2 will be linked to 2. 16 will be linked to 16. And you see that you have 16 several times because this is a history table. So this person more than likely started off in one department and moved to another one eventually, but it's the same person, which means that if we look back over here, we know that this marketing manager would have moved departments at some point. All right. So once again, just giving context. So we need to link business entity ID table to business entity ID having table. So over in our query, I'm going to introduce a new keyword or new keywords, and this one is going to be called inner join. So that's a keyword to say that I wish to join this table with another table. So the other table will be human resources dot employment department history. So here the statement once again, and I broke the line so it could be a bit more readable, but once again from left to right would be select all from this table with an inner join onto that table. Then we need a condition. So I need to say on, and then the condition is that the column that they both have in common have the same value. That's the condition. So business entity ID from this table must have the same value as business entity ID in that table. Now, it is a mouthful to write this out. It can be difficult to write this out and it gets very messy because I'm going to have to say table dot business entity ID is equal to, and then the next table, and you see this is long and it's becoming very confusing as I'm typing this out. All right. So, and if I was to make this a bit smaller, it would be easier on the eyes and you'd see it a bit better. Well, I don't know if you'd see it a bit better, but it would be a bit clearer that everything here is one line. So we're joining this table on the condition that the business entity ID, column is equal to HR.employee department history business entity ID. And that can be very difficult to type out. So here's where I'm going to introduce the technique of aliasing tables. And this is where it becomes very, very useful. We can actually, just the same way we aliased our columns earlier, we can actually alias our tables as well. So for short, instead of typing out human resources dot employee, I can actually just say as EMP. Right? So now, within the context of this query, anytime I want this table, I no longer call it by its right name. I'm going to call it by its short name. And that is why this red line appeared, because now this name is no longer the name that it identifies by. So I have to say EMP. And that can help me to reduce the amount of typing. So the same way for employee department history, I can call this one HIST for short. And then wherever I need it elsewhere in the query, I just use HIST, and that would have shortened it. So now when I zoom back in, it's, I guess, a bit easier on the eyes, so to speak, to read. But I'm sure that you can see the value of aliasing the table. All right. So now we have select star from, and then this table, which identifies as EMP, and we're inner joining it on human resources employment history, which identifies as HIST, and then on the condition that EMP dot business entity ID has the same value as HIST dot business entity ID. Now, when I select that, this is what we end up with. So between this column to this column, all of those data points represent the employee table. And then if you look to the right of that, you'll see now we have similar data coming from the employment history table. And here's our 16 repeated, right? 16 is repeating. And you'll see here that department ID for 16 is different in the two spaces. So that means this person moved from department 5 to department 4 at some point. All right. So now department ID means nothing to me. All right. I don't know what department ID is. So what we want to do is actually bring back the actual name of the department so we can see what departments each person is in and what department in particular, this person moved from and to. So what are we going to do? Well, if you said inner join another table, then you're absolutely right. So there is no real limit to the number of tables that you can inner join. And the fact is that as many tables as it takes to get the data, you may need to do that. And that's one of the downsides of normalization. While it helps to optimize storage, it is not very good for retrieving data. But we have to do what we have to do to maintain proper database design. So we're going to inner join again. And this time, and I'll just kind of keep the line breaks so that we can keep the same form factor. I'm going to inner join and I'll just bring over the department table And guess what? I don't want to write this out, so I'm just going to say dep. So that's the short name for the department table, on the condition that dep.department ID is equal to, and remember that you are joining tables that have columns in common. So department ID is in both the department table and the employee department history table. It is not in employee table. So I can't directly join department onto employee because they have nothing in common. These two have something in common, which is the department ID. So dep.department ID is equal to hist.department ID. Now when I execute this query, the data set just got a little longer. So here to here, employee, we know that already. And then we can say here to here is department history. And then guess what? The rest is department. So you see, as many tables as you join, the list just gets, well, the left to right data points just get more and more. And especially since we're selecting star. So when we select star, it's going to select star from employee, star from every other table that is being joined. All right. So beware of that. Now that we have our data and we can see, everything that we need to see within the context of this activity. And here we see that this person moved from purchasing to marketing, right? So that's employee with the ID 16 moved from purchasing to marketing. So now we're starting to see the meaningful data points that we can actually use to create a report. So when we get to this point and we see all of the data, then we want to refine our query. So we want to replace that star with the actual columns that we want. Now let us say that I wanted job title, right? And while we're looking at aliasing, we can always make it out to be more presentable. We also want their hire date, and I'm just making this up as I go along, right? So I have no real method to my thoughts right now. I'm just picking out data points that I think would be relevant for this kind of activity. And I want to see if they are salaried. Let's say salaried flag, and paid employee. Right, so that is the column name I want. So like I said, you can type any type of column name as long as you wrap it in the square brackets. So we have job title, we have when they were hired, we have if they are salaried, and I want to see their department. So I'm going to say name. Now, note that sometimes names or columns repeat across the different tables, right? So in this case, we don't have name repeating, but name is a very common column that you may end up repeating across multiple tables that you end up joining anyway. So just the same way that we had to specify the table alias dot the column and table alias dot the column, because if we didn't do that, you would actually complain about it being ambiguous, right? Ambiguous column, because it's seeing one big data set and multiple department IDs. So which one is it that you want me to select? Should it be from this table or from that table, right? So it's very important to prefix that column name with, if not the table name, then the table alias. So just to drive that point home, sometimes name will appear multiple times. So it's important to say something like, this would be the, I'm sorry, I'm just looking back. This would be the dep. So dep dot, and then we say name, just to make sure that we know which name column or which column it is. But our alias has to be very explicit, department, right? So anybody reading it would know that whatever word they see here represents the department. And I think that this is good enough. Let's run that and look at our nicely cleaned up. There we go. Nicely cleaned up data set. So now we're seeing everybody's job title, when they were hired, if they're paid, and the department. Now this could be useful. It could also use a bit more information. So my challenge to you now is to look through the other tables, figure out where you could find maybe the person's name, the employee's name, right? and join on that table and add their name to this query. But for now, at least you understand the concept of how to join data. Now, you do have different kinds of joins. Right now, we're doing the inner join, which is the simplest of them all, but you do have the concept of a left join and a right join. So in the next lesson, we're going to look at how the left join differs from the inner join. Welcome back, guys. In this lesson, we're going to be looking at left joins, and we're going to be looking at how we can even mix and match our joins and why we would need to consider mixing and matching them. To accomplish this, we're going to move away from our human resources schema, and we're going to go over to production. So in this scenario, we want to select work orders, the product that the work order was done against, and then their scrap reason. So once again, we always want to start off with our analysis. We want to see the different tables, how they're interconnected, what data is available to us, and then we can make our decisions. So using the quick query, where we just right click and say select top 1000, I was able to look at the products. So here in the product table, we see, well, the details of the products, right? The adjustable race, etc. So we can see that these are the products, up to 500 products are in the database, and that's fine. Then we can look at the scrap reason. We did say we wanted to see the scrap reason. We see that it's just a metadata table, meaning it's just a list of reasons with an ID and a name and a modified date. So nothing too fancy going on here. But then we'll go over to the work order table. We see here that we have, yes, a work order ID. We also have a product ID. So that means this work order is relative to a product. Each work order entry is relative to a product. So one product could have had many work orders done against it. And you also see here that there's a scrap reason ID. Most of these are null, however. And then you may see that maybe there's a scrap reason in some of them. So in joining these tables, we need to consider what might be null versus what would never be null, because you can't have a work order without a product, right? So let us start off. So product would be the root of it all. So I'm going to say select star from, and I'll just drag over that product table. So now we have all the products. That's fine. If we want to, we can actually start refining the query from here. So I could just call this prod from right here, alias it, and then break down exactly which columns I want from prod. So I can say I want prod.name, right? I could also say maybe I want prod.product number. And I think I'll just do that for now with prod. I don't need any other detail for the context of this query. So I know the name and I know the product number. Now, I started refining the query, but I still don't know really what data points I need. So I can always jump back over to the other query windows. So I know about products now. I can close this one. Now, I am looking at scrap reason, and there's nothing from scrap reason to product. I can't link scrap reason directly to product, so I'm not going to focus on that one just yet. But then I see in work order that there's a product ID, and I can see each work order done against the products. So going back to what we just learned, now we're going to inner join the work order table, and I'll just drag that one over, and I'll just call this one WO, work order, on the condition that WO.product ID is equal to prod.product ID. Once again, when you have the same column present in multiple tables, it can be ambiguous if you don't precede it with the table name or the alias of the table. All right. And once again, aliasing makes this part of the query much easier to write. So now when we do this and I run again, well, I'm only seeing prod name and product number. I'm not selecting anything from work order. So obviously I would want to see certain details from the work order. And so the details I would want to see are maybe the ID, work order ID, the order quantity, and stocked quantity. So let's do that one. So WO dot order quantity and WO dot, what was the other one that I said? We wanted stocked quantity, and WO dot ID, work order ID. And I'll actually put this one at the top, right? So now we have product, and I'm missing a comma. Do remember your commas, very important in the syntax. So now I'm selecting all of those, and do remember not to end with a comma, right? So let me run this query, and now we're seeing the name of the product, the number, the work order, the order quantity, the stocked quantity. All right. Then the final thing we want is a scrap reason. Now, I don't want to see a scrap reason ID because this means nothing to me, right? In the grand scheme of things, seeing 7 and 11 don't mean anything. So instead of showing 7 and 11, I want to actually show the actual data if it is present, which would be the actual name. So that means I need another join, correct? However, I can't use an inner join because it's going to want to make sure that the data can be found on both sides. And that's what inner join means. So I'm going to do an inner join and show you why it would be a bad idea to use the inner join, right? So we're going to inner join on scrap reason, and I'll just call this SR on SR dot scrap reason ID, and which table also has scrap reason ID? Work order. So it's going to be is equal to WO dot the same column, scrap reason ID. Now note, I have 72,591 rows coming back from this query. All right. So just the query that I ran earlier, where we joined the production work order on the production product table, we got 72,000 rows. Sorry. Now, when I run this one with the inner join on scrap reason, that number is going to dramatically fall to 729. Right? And let me just add the SR dot name. Once again, name. Be very clear which name you are referring to. All right. So here I see only 729 rows. Now this would imply that there were only 729 work orders, right? And that is where the data can get skewed. The reason for this, once again, is that the inner join is checking to see that these two values are equal, which means that whatever is in the scrap reason ID on the scrap reason table must match what is in the scrap reason ID on the work order table, which we know may not be the case because in the scrap reason table, this is never null. But in the work order table, there are several nulls. So what this is doing is actually eliminating every row that is null, because null is never equal to a value. So this one comes back, and all of these are ignored, which we don't necessarily want. So that is where we have the left join. So a left join basically says, so instead of inner, we say left join, and the left join would say, give me everything on the left, and if you can find values on the right, then bring them back. Now, you're probably wondering what I mean by left and right. So I'm going to have to zoom out again and show you the statement in one line. So literally, a left join says, what table is to the left? This is the table to the left of the join statement, right? Because directionally, this is your left, right? So inner join means look at both. So that's like in math, we would say an intersect, whereas the left would be more like a complement, right? So give me everything to the left, and if you can match to the right, then fine. So everything in the left and try and match with what is on with the records in this table that meet that condition. If you can't match, that's fine, still bring it back. If you do match, then you will see the details. So now when I run this, I'm supposed to get back 72,000 rows, but some of them will just have null because I was unable to match it. So the name of the scrap reason here is null. And then where there is a scrap reason, I can see it. And that is how left joins work. And really and truly, like I said, it's directional. So a right join would just be the opposite. So the right join just means bring me everything back from here, and if you can match it with what's on the left. Directionally, for me at least, I always use a left because it just feels more natural, right? But you can decide which one you want to use. And that is really all there is to the left join and right join. And then, of course, you'd want to clean up your columns because you have two columns called name and name. So I'll leave that to you for your activity. Go ahead and clean up those column names and make sure that they represent what the data in the actual column is. And I hope you got a better understanding of the left join. It does take practice and it does take intuition and analysis to know when to use which. Generally speaking, however, you can always rely on the left join to bring back all the data anyway. So you can't go wrong, generally speaking, just using left join all the time. But in specific situations, maybe you really just want to see the work orders that have a scrap reason, and then you would want to use an inner join. So it's good to understand them and it's good to know when to use them. When the boss says, tell me all the work orders that have scrap reasons, then you inner join through and through, and you have 729 work orders or records rather with actual scrap reasons. And that is how you go about joining records even when the condition might not be met on both sides. Next, we're going to look at the union and union all operations. Welcome back, guys. In this lesson, we're going to be looking at union and union all. Now, the union command is used to join two different datasets from two different tables into one contiguous dataset. What does that mean? We already looked at how we join data points for a record across several tables, and that's when we use our inner join or our left join or right join. So when we want to see more details about a particular record, when the details are in other tables, then we use joins. However, let us say that one table gives us all the details on a certain entity or entity type, and then another table has similar details on another entity type, and we just want one big data set of everything to be printed out. That's where we would want to union the two different data sets. So here I have the example and I kind of wrote out some of the queries already, and I'm going to walk you through exactly what we're doing. So the scenario is that we want to select all customers and employees into one data set. Now, the context for this, let me make this a little bigger so that we can make sure that we can see, is that we have been looking at the human resources employee table. And if I execute this one, you'll see here, yeah, we get details about somebody who we can safely assume is an employee, but we don't know much about them in terms of personal data. Now, there are other tables here. There's one called person.person under the person schema, and there's another one called sales.customer. So under the person schema, if we were to look in the person table, we would notice that we have several persons, 19,972 persons to be exact. Now, based on what we've gone through with the employee table, we can see that there are roughly 290 employees. And then if we look in the customer table, we can see that there are 19,000 and some employees. So for this example, we're going to be manipulating our data a bit to make sure that we get a data set that we can union from these three tables. So let's get to it. So these are the individual select queries. I don't necessarily need these going forward, but I am going to reuse some of the join techniques. So what do I want? I want, let's say, just the first name. So I'm going to say I want person dot first name, and I want that from, and let us start off with the employees tables. Now, obviously, I can't get person dot first name from the employee table. So what do I need to do? If you said join, then you're absolutely correct. I need to inner join on the person table on the premise that, and I'm just going to go ahead and shorten my table names with aliases. So person is now per, and the employee is now EMP. So it's going to be EMP dot business entity ID is equal to person dot business entity ID. So now I will be able to see all the first names of all the employees. We couldn't see that before because we needed to join onto the person, and that's fine. Now I'm going to do something similar, but for the customers. I want to see all the first names of the customers, right? So I'm going to say, give me cost, or rather per dot first name as well, because I can only get first name from the person table. But I'm selecting from sales.customer, and I'm just going to call this one cost, and I'm going to inner join on person called per, right? So I'm just copying and pasting to go faster. And you see I'm actually kind of breaking my own rules about using all caps just to display the keywords, but I think by now we know the keywords, so that should be fine. But I'm going to say per dot, and then the primary key once again is business entity ID, and here's where data analysis comes into the picture, because if we look at the sales.customer table, there is no business entity ID column here. The only column that could possibly be a link to the person table would be person ID. So sometimes when we're doing a join, the column names don't match evenly, right? So in our previous example, we saw product to product, scrap reason to scrap reason. In this case, we saw business entity to business entity ID. And now we're going to see that business entity ID has to be inner joined onto customer dot person ID. So once again, it's very important to analyze the data and the tables that you're working with. Now I can execute both select queries simultaneously, and that will result in two distinct data set areas in the results pane, right? So up top would be the employees, and below would be our customers. Now, what do I want to do? I want everything to be in one contiguous data set. So like I said, this is one result pane by itself, and this is one result pane by itself. But I want to be able to just export everything all at once. So that is where we have union. So when you have two select queries that are selecting basically the same data points, they have to be the same data points, as in the same columns going across, then you can simply stick a union in between them. And once you say union, what it will do is join everything into one big data set. All right. Now, please note, let's look at the numbers. We have union, and we have the concept of union all. And I'm going to show you why you may use one and not the other. Now, when we look at the customers, we have 19,000 records from this one query. And then, of course, we know that we have about 200 employees. But when I select everything with a union, I only end up with 936 rows. So why is it that I'm reduced from the 19,000 here to just 936? Well, what union does is, and that's part of the reason I'm only using one column, which is first name, several people may end up having the same first name. And of course, we can expand this, but remember that the union only works when you have the same columns being selected from both queries. So whatever data points you add have to be present on both sides. But my point here is that because we're using first name by alone, the first name may repeat. So if you have several Johns, several Jones, several Forrests, etc., the union is actually just going to discard the duplicates and only bring back one. So here we see that, yeah, out of the 19,000, there were several duplicates probably, and even worse, when we joined onto when we unioned with the employees, there were even more duplicates. So the union just says, okay, discard the duplicates and bring back the distinct values, and we ended up with 936. Now let's look at union all. Union all, in contrast to union, is going to bring back everything. So now we're ending up with 19,000 and more than just the customers. And that's because it's actually joining everything here with everything here, and it is not taking it on its head to try and figure out what is a duplicate or not. It is just saying, I'm going to join everything that came back. So union will discard duplicates, and union all brings everything back. So once again, just know when to use them based on your situation and how best to manipulate your data so you can use a union when necessary. Welcome back, guys. In this lesson, we're going to be looking at the concept of grouping, and we're going to run a contrast with the concept of selecting distinct. So I would have used the word distinct in the previous lesson where I mentioned that the union will actually bring back the distinct values from a data set, meaning it eliminates the duplicates. And that's exactly what distinct does. Now, you may not need a union, but you want to be distinct. And in a select query, and I'm just reusing the same select query that we used previously for our customers. When we're using this kind of query and we have the risk of having duplicate values, then we can easily say distinct before we start listing the columns. So what this keyword does is it says when you're selecting the data and the columns, please look if you have any two columns that look the same way with the same set of data. If you end up with that, then you can discard it. And that's all distinct does. So if you realize that when you run a select query, you're ending up with duplicate values and you want to eliminate them quickly, you can easily use a distinct keyword and your query will be cleaned up. So we know that without the distinct, we should get back over 19,000 records. But look at when we introduce the distinct, now we only get back 871 rows. And note that distinct really works relative to the column. So the more columns you put in and the more variations of the data, obviously, is the less distinct the data becomes. So first name, it's easy to eliminate all of the Scots, but then you may have several Scots with different last names as well. So if I was to put in per.last name as well and run that, then that number is going to increase because now you have several Aarons who have several last names. So it's very important that you make sure that you're getting back the correct data because prior to this, there was only one Aaron coming back. As far as the data set was concerned, there was only one Aaron here. While we're in the mode of writing more complex queries, let me throw on an order by. So I'm going to order by the column first name. And by default, it will be ascending, so Aaron is at the top. So like I said, Aaron only came back once because distinct was eliminating the duplicates. Now, I am adding on a variation to this duplicate, to this data set, sorry. So now, Aaron is no longer seen as a duplicate because distinct also has to take into consideration the last name. So Aaron Adams is different from Aaron Alexander, etc., etc. However, all Aaron Alexanders, all the duplicate ones, have been eliminated because you see, we're still not bringing back the full complement of the data that we would have seen prior to putting in our distinct. So now that we see how distinct works, let's look at the group by. Now the group by does a similar function, but it adds a bit more functionality and usefulness to the data after it eliminates the duplicates. So when we do a select query, and I'm just going to duplicate this select query so I don't have to retype it. I'm going to remove the distinct and let us just do this select by itself. All right. So let me comment out the distinct. So now we have a select query where we're bringing back 19,000 and so on rows, and we're familiar with that. Now, when we do a group by, it is usually in an effort to actually clump the data together. So while distinct will see two and eliminate the second one, keep one and eliminate the second, third, etc. What group by does is it actually clumps them, but it keeps track of how many records it clumped. I hope that makes sense. So in the case of Aaron, where there are several Aarons, let's say there are about 50 plus Aarons in the system, right? The distinct will just keep one, discard all the rest. The group by, however, will actually remember that even though it's displaying one Aaron, it actually clumped 50 Aarons into one Aaron for display. So For this example, let me remove the last name, and I'm going to add a group by. Now the group by has to come before the order by. So I'm going to say group by, and then for every column that you are selecting, you have to group by it. All right, so that's the tricky part with the group by. So if you're selecting one column, you have to group by the one column. And then what it's going to do once again is clump all of the arons, because you saw that there were 50 just now. Now it's only one for display, but this functionality is actually tracking. And we're going to see the relevance of that in the next lesson when we look at the aggregate functions that go with the group by. But for now, just know that that is what the group by does. So while it seems like it works just like a distinct, it does give us a bit more functionality in the backend, in the background, and we can do some more operations with the data that comes back. Now, similar to the distinct, however, the more data that you add is the less effective that the grouping becomes. So let us try to add the last name value to this query, and then when I run, I'm going to get an error, and it's saying that this column is invalid in the select list because it is not contained in either an aggregate function or the group by clause. So like I said earlier, every column that you select needs to be in the group by. So if I'm selecting first name, I need it there. So since I'm now selecting last name, I need to also group by the last name. So the group by knows that when it's trying to clump, it should be looking at both of these data points. And then when I do that, the grouping is going to bring back the same kind of result that we got from the distinct. However, in the backend, whatever was grouped, it knows how many of them, it's tracking how many of them were grouped and what the values were. So when we come back, we're going to look at the aggregate functions, and we are going to build on how this group by clause can help us to bring forth useful statistics. All right, guys, welcome back. So in this lesson, we're going to be taking it up a notch with the group by concept that we looked at just now. And we're going to be looking at aggregate functions and how they work. And here we're going to kind of step out of the person exploration again and start looking at numbers, but we'll do it in, step by step. So what is an aggregate function? An aggregate function is a function that allows us to return certain statistics on our data. For instance, if I wanted to find the number of customers, yes, it's easy to run a select query and then just look at the number of rows that come back. But for obvious reasons, that's not the best way to do it. What if I wanted an actual number, maybe for a report or for something else? What kind of query could I run? So it's a simple query, really. An aggregate function can be put into our select statement, and I can just say select count star. Here star means all, or I could be specific with the data point. But let us say that I'm going to use the previous query. So let me reuse this select query where we did select distinct, and I'm just going to modify it a bit. So I'm not interested in selecting distinct, but this time I want, let us say, and let me just say all the first names. I want to see all of the customers. So I want back one value. So here I can say, give me the count. And this is a function, which means I have to open parentheses and put in what we'll call a parameter and close parentheses. Notice the color coding on the function. So function is an aggregate, count is an aggregate function. And then we're saying, give me a count of this value from this query that we have written. And then when I run it, I'm getting this error saying that it's invalid in the order by clause. And that makes sense because I don't need to order by count. All right. So sometimes it's good to just read the error message, understand what it's saying, because as we learn, as we hone our skills, we are going to write statements that are invalid. So it's important to be able to read the error message and see what it complains about and know how to fix it. So let's try that again. Now look at that. I'm just getting a single value, nice, single and simple value, stating how many records are in that query. All right, so that is your first example of the aggregate function. So count is one of the easiest ones to use. Now, what if I wanted to find the number of customers with the same first name? Now that's slightly different because now I need to know what the name is and how many times that name appeared. So that is where we use our group by, because remember that we need to actually keep track of the number of times that name was clumped together. So let me remove this additional column. I only want to select the first name. So I want the value to show, right? But guess what? I also want the count for each time this value was shown. So count here is just acting as another column. I noticed that for the previous query where I just did count as a column, it said no column name. So that means I would want to alias this. So let's say as number, right? And if you're using one word, you don't have to put it in square brackets, but just be consistent. I will do that. And as the query gets longer, I have to break the line so we can see what's happening. So I'm selecting first names, and I'm selecting the number of times these first names appear. And then here's what is key. Remember that I said that a group by is actually keeping track of the number of values that it's actually grouping. So when I do this and execute, you're going to see, and let me comment this out so we don't get an extra result set. Let's do that again. Here you're actually going to see that Aaron appeared 54 times, Abby appeared 19 times, these appeared once each. This one 76 times. There were 52 Adams, etc., etc., etc. So I was able to select the name, group it, and then because of the grouping, I'm able to see the number that appears, or number of times that value appeared. Obviously, if I put on last name, then the counts won't be so high, but at least then I would be able to see how many times a last name appeared more than once. Which brings us to another activity. How would I be able to see the number of times, the number of duplicates, right? So if it appeared once, then it's not a duplicate. If it appears more than once, then obviously it's a duplicate. So I only want to see the duplicates. Now, generally speaking, we would use a where clause to say something like where one column has a certain value, but with a group by, we can't use a where against an aggregate number because this value is an aggregate value. So what I have to do is after I group by, I use the having keyword and then state my condition. So here I would say having this aggregate number greater than 1. Look at that. So now our SQL statements are getting a bit longer and a bit more complicated. Remember that you can always use a where clause, but the where clause can only apply to values that are being selected here. So I could say where first name is equal to maybe, let's say, Aaron, right? But then when I want to filter based on the aggregated value, courtesy of my group by clause, I have to say having and then use that aggregate function in the condition. So if I do that, then obviously I'm going to get back Aaron with 54 because I did that where clause. If I didn't do that where clause and filter out relative to Aaron and just said I want everybody all the first names, having a count of more than 1, then I'm not going to see any name come back that's 1. So notice that A full stop doesn't come back, and those other names that were only appeared once do not come back. And then I can also order by this value so that I can see them in whichever order, whether ascending or descending accordingly. Right? And now you see that there are only 615 rows coming back, courtesy of that grouping and aggregation. So that's how aggregate functions can help us to maximize or, just see deeper insights into our data if we need them. Now let's look at another scenario where we may want to find the total, average, lowest, and highest amounts. And we're just going to do all of these in one query using one table. So this is going to be fairly simple. We're just going to look at the different aggregate functions that are needed to get these values. So let us start by selecting from our table. I'm not going to select star. I could select star, but of course, when you select star, the variations that exist across the data set will skew your results. So you want to be very careful and deliberate with what you are selecting. In this case, I'm after the total due because I only want to see the sum of the total due values and the average and all of these things, right? So I'm just going to select total due from our sales order header table, and let me be consistent. So when I do that, I'm seeing that there are over 31,000 sales that have happened. All right, 31,000 sales. So for all of those sales, I want the total. So I can simply wrap this in a sum function. And guess what I'm going to get from this? One big value showing me the total number. I don't even know what that numeral is. I would love to have it in my bank account, but we'll get there eventually, right? So that is the total for all the sales that have happened in this database as at the time this query is run. So now we have the total. What about the average? The average amount. So for the average sale, right, how much do we make? Well, for the average sale, we make $3,915. All right, that's a little lower than I thought it would be considering the total, but we can work with that. All right, so what is the lowest sale? Well, we have min, short for minimum, and then we say what is the minimum value, the smallest value in that column for this entire data set. Once I do that, I'm going to see that $1.51 was the smallest sale. That was probably the very first sale when we're giving out samples. All right, now let us see what was the highest sale amount since we have started this business. And the highest sale amount was $187,487. So we see the different values here. Now, obviously, there are no column names. And if you said that we need aliases, then you go ahead and give yourself a pat on the back. You are right on the money. So I'm just going to reformat these a bit. And then here I'm just going to say total sales amount. So that's column 1 for sum. And let me write sum in all caps just to be consistent once again. And then I'm going to say average sales amount. Then we say lowest sale amount and highest sale amount. All right. Now this is a snapshot view of what's in the database, what we have done, all the business that has been conducted up until now, and some executives somewhere in the organization might just find this useful. Most importantly, we know how to get these values. Now, when we come back, we're going to take this a step further, and then we're going to start looking at more advanced concepts with our aggregation and summation, because right now we're just looking at all of the sales. But what if we wanted to actually see all of the sales that were conducted by a particular salesperson, and then relative to that salesperson, we wanted to see what was their highest sale, what is their lowest sale, and what is their average sale amount. So when we come back, we're going to take it up a notch with our grouping and joining and look at how we can properly see insights in our data. All right, welcome back. So this lesson is going to be more like a workshop than me teaching, because now we're going to combine some of the skills that we already know and do some deep analysis to make sure that we're getting back the right data. So now what we want to do is per salesperson see their stats on, the different amounts of money that they have brought in for the company. So we also need to look at the salesperson table. So let's take a quick look at the salesperson table to see what data is available to us here. All right, so in our salesperson table, we see that, there's an attempt to capture a year-to-date value for their sales, but I don't want to trust that. I want us to build out our own report because we don't know what system is updating this. We don't know if it's stale data. We want to be able to pull a report that sees the data as it is at the time it is being pulled. So salesperson gives us a business entity ID, which simply means to me that to see their additional details, there are salespersons, which makes them a person. and their person details would be in the person table. All right. So that means we need to run a query that will join our person table onto our salesperson table, and then our salesperson table onto our sales order header table. And then from here, after we've combined all of that, then we can start manipulating our data to bring back our stats. So let's get right into it. So let me comment out our previous query. And I'm not even going to write the scenario. I'm not going to bother to do that now. We're going straight into the action. So let us select star from, and we can start off with salesperson, right? So we want to select star from salesperson, and that salesperson table. Sorry, let me just find it and drag it over. All right. So we're selecting star from that table. That's no problem. Then I'm going to inner join this table on, inner join it with the person table. And let me just call this P and call this S. So sometimes you may see persons use aliases as just letters. It's fine. It's just that as the query gets bigger, it becomes less readable, because P really means less than per, and per really doesn't mean anything. It doesn't mean what person means, right? But just a little tip there. So person alias that's P, we're joining on business entity ID being equal to S dot business entity ID. Now when we do that, we can see for each salesperson, we can see their first name, last name, and that kind of stuff. All right. So I think that's good. Now we need to join onto the sales order header table. So I'll just copy this since I'm already there. And of course you could drag it over, but we need another inner join, and then we have our sales order header. So I'm just going to call this SOH, sales order header, and we're joining that on SOH dot salesperson ID being equal to S dot salesperson ID. And there's no salesperson ID here, which means that clearly I need to use the business entity ID. All right. So remember that little assessment that needs to happen, because business entity ID is our resident ID to identify the person in the person table. So it's kind of the obvious choice for the salesperson ID, but not really. So make sure you do your due diligence. Now that we've joined all of these together and we're still selecting star, we can see everything from left to right about any one person. Notice that the persons start doubling up now, because I'm now joining the person onto the sale. So that means this Michael Reiter person has a sales order ending 59 and another one ending 60, right? And for those two sales, I can see the total amounts that they have collected, or he has collected rather. All right. So, of course, obviously, the data is going to duplicate, because for every order that this person put in, there's going to be a row. All right. So now what we need to do is kind of refine the columns that we're looking at. So I definitely want to see first name and last name. And I'm going to just break line and start typing that out. So P dot first name, comma, P dot last name. What else do we want to see? Maybe for our purposes, for now, we only need the total due. So S dot total due. Is it S? No, it's SOH dot total due. There we go. So now we can cut this down now to see each person and the sale amounts that they have brought in. So Jose has brought in these two. Svi has brought in these two. Jose appears several times. So Jose is working hard. All right. So now what we want to do is kind of group them, because I don't need to be seeing Svi all the time and I don't need to be seeing Jose all the time. I want to group them. While grouping them, I also want to see the aggregated values for the total due. So let us start off with the sum. If I say give me the sum, I want to see for each salesperson the total amount of sales that they have in the system. I can now say give me the first name, give me the last name, and sum total due. All right. So instead of individually selecting these, just sum it and tell me. Now, when I do this, you're going to see an error saying that it is not contained in an aggregate function or the group by clause. So in this situation, sum will not work because I have other values. Unlike previous where all I was doing was selecting sum alongside other aggregations against the entire data set. In this case, we have a more vested interest where we have the first name, the last name. I know you're asking me to sum, but what am I summing? Well, I can only sum after you group. So you need to tell me that I need to group by the first name and last name of everybody. And after I have grouped them, I can now sum the values that I am attempting to group. So every time you see Svi Reater, I think that was the name, then go ahead and sum or add to the summation. Every time you group him, add that total due value to the summation. Right? So I'm going to call this total sales. Now, when I run this query, look at what happens. We have a much shorter list, right? Now, I think we're coming from 3,000 and so on rows. Now we're down to 17, as is correct because there are really only, let me go back, there are only 17 salespersons. There were many more sales, right? This is select top 1,000, but I mean, if we remove that, then I'm sure there would be far more sales than just 1,000. Now we're down to 17. So now we're seeing each sales agent and I'm able to see their total sales, right? Now, what if I wanted to know their average sale? Well, it's about the same thing. So here's what I'm going to do. I'm just going to copy these lines that we wrote already and uncomment them, so I don't have to write them again. But the fact is, now they will work relative to the grouping. So relative to the grouping, we'll see the sum. We'll see each person's average, each person's lowest sale amount, and each person's highest sale amount. And then when I run this, now we're seeing everything. So Syed has this much in sales. That's his average sale amount. His lowest sale was for $62. I guess this is when he was an intern, right? I know he's a superstar where his highest sale amount was $65,000. And the list goes on. And that is how grouping and aggregate functions work. One more useful metric I think would help would be to add the number of sales. So I can say count and count the same column, right? And then we'll just say number of sales, because it's kind of hard to say, well, somebody's average sales is X amount when they've only sold one thing, right? So at least we get a little context that Saeed has sold only 16 things and he has amassed that amount of money, whereas Michael Blythe has 450 sales and that's how much money he's clocking. All right. So those are, once again, useful metrics that give a snapshot view of how your sales reps are working. And you can, of course, apply these concepts to other parts of your system. Now, one thing I can appreciate is that these values are not very clean to look at. So when we come back, we're going to look at how we can manipulate them. Right now, what they're called strings, because they're really coming back as text. So we'll look at string manipulation and how we can use string manipulation to clean up our data as it is displayed.
So guys, this is an extract from our Udemy course. To continue your learning to the advanced level, you can enroll in this course on Udemy, where we cover more advanced concepts such as CTE, transactions, creating tables, you name it. Almost everything you need to know in SQL. So that's it for now. Thank you for watching and don't forget to subscribe to our channel. The links will be in the description of this video.